Hello, welcome. I'm Bill Wake. We're working on a basic interpreter. We've done most of the expressions except for string arrays, and we're going to do those today. This is actually kind of a catch-up section or make-up session. I screwed up something in the recording this morning, and so I thought I'd just do another quick session here, walk through the changes, and we'll pick up with something new tomorrow. All right. So we've got, well, let me just go back here. All right, so these are the changes from today, and we'll run the comparisons. All right, so store array value, this I just made a spacing change, putting the parameters one per line. All right, but the real change is down here. We've been storing, well, our store, our list, our variables, basically this thing globals, or sometimes it's a store. That is based around values. So it changes, goes from a string name to a value. And the value type basically wraps up integers, numbers, floats, kind of the same thing, and strings and various other types of values. But for the arrays, what we did was we just stored an array of integers inside the value. So the array value type value contains an array, and we just used array of integer inside it. We want to generalize this to strings. Okay, so first step is I want to make this array hold values instead. So we can change the type and just return value subindex. Okay, so values, let's see, comes in here from the array of number. So that's the value type stored in there. And we'll make it an array of values. So this, we don't need the dot number anymore. All right, down here is dodim. Oh, here's another place we did this. We were converting our values into floats, and now we're just taking the value we get, and that's the value we're going to use. Okay, here you can see the difference. We went from array of float to array of value. So this is dodim that either explicitly or implicitly produces the array that we are going to hold for this thing. All right, and so since it's array of value, we have to put numbers in it, or other strings and stuff. We're putting numbers in for minimal change. We're just putting in the number. Okay, so instead of 00, a float in the Swift domain, we're doing dot number of 0.0, a value in the basic domain, or the basic implementation domain. All right, and value, that's spacing, but here you can see we changed array of numbers to have the dimensions, and the values are no longer floats, they are now values. All right, next change. Okay, we're going to rename, so this is just some renames. Array of number, let's not call it array of number because we're generalizing it. Let's just call it array. All right, and down here we've just changed the name. So this is mostly a name change. There's name and name and name. All right, and then value actually held the rename. Array of number goes to array. And there was a change in the test too. Oh, we just had to, our array, our answers, expectations have to be that we're looking at values instead of raw numbers. Okay. Oh, that's a rename. Maybe they're all renames. We already did that step. Okay. Next one. All right. So there are two things. One is there's the notion of a test scheme. And I had tests that are both unit tests and UI tests. I just took the original dummy UI test that gets generated. It still takes like multiple seconds to run, so I don't want to run it all the time. So doing this scheme method lets me turn that off and just run the unit test with Command U. And then in the over here, we started saying, okay, dimensions ought to know types as well as names. Okay, I guess we should start in parse. Okay, dim, it used to be the name of the array and the list of dimension sizes, And now we've added the type of the elements. All right. So before it implicitly stored number, and now it stores the type itself. Okay. And so to make that explicit here, we used to just store this. Now we pass in number. So I'm not shifting over to strings yet. I'm just kind of getting everything laid out in a way that makes sense for it. All right. Then the interpreter, we're not even looking at it. We just get an underscore back that just means ignore it. Okay. So again, part of just making it work for the existing code. All right. Now we're going to do the real work. We want strings to do something. All right. So parser is going to include the type. Okay. We've already calculated it. I renamed it to type, but it's got the type on the variable, and then it passes the type back with the array access. So notice it used to hardcode number. Now it gets the actual type from the variable. So a string variable, if you dimension $1 with 10, then the type is string because the variable was a string. Okay, so we take this type of the array from the type of the variable. And then the interpreter, well, now we were just passing nothing and ignoring it. Now we got to pass the actual type. All right. And there's one call. I think we have 2 or 3 more. All right. Yeah, here we pass the type along. It was store array value. That was a bad name because it was actually fetching array values. So I changed the name, added in the parameter, and the parameter passes in down to do dim. All right, which dimensions the new array. Okay, and this one, this is again passing type along. So it was ignored. Now it's passed in. Notice this is still int. We're still not fully converted over. All right, but do dim, if you pass in the type, instead of hard coding it to 0, now it says, hey type, what's your default value? So the default for numbers is 0. The default for strings is empty string. So this populates a new array with the proper value. And it knows that value because it was now passed in. Okay, we looked at parser. All right. And so, the number, I think I misspoke. The number was the dimensions, so the number's okay. All right, so with that finished, so we got the string arrays working, and we wanted to try some cleanup in this scanner, the lexer. And what we need to do there, or what we want to do there, is there are a bunch of simple tokens like plus and greater than or equal and so on that you can match just like a keyword. You just look at the front of this input string and say, does it match? Instead of, we've done a more character by character kind of scan. So let's delete some dead code, comments outs, and down here, we're going to do a different way of finding the front of the string. So on the left side, we skimmed through looking for letters followed by $, because all our reserved words, keywords, start with letters and then maybe have a $. This is actually not great because it's building up a brand new string. So it builds up a string here and then appends to it, and then we use that string in our match of the keywords. Okay. But instead over here, we've taken a different approach. We're just going to get the front end of this string coming back. Oh, that's not going to help. Okay. But anyway, program indexed by the start index offset by index, and then the input is the starting index going on. So that gives us basically a substring of the input that we can match against. Okay. So instead of value being computed, we're using input that's just passed in, or the front of what's passed in program. And the flip here is the old code. If the answer was nil, it just returned handle variable right away. In this code, we want to flip this. So if answer is not nil, do the other stuff, and if you didn't return, then handle variable. And the reason I'm doing this is I'm trying to get the keyword stuff pulled together and the variable stuff pushed to the ends, to the edges. Okay, so now the work is in here. More dead code. We got these keywords and names. What we're going to do is kind of take the top. It's almost like I inlined that function and then re-extracted it. I didn't. I did it manually, but it would be the same effect, or practically the same effect. So if we ignore the variable stuff, we're going to do that after we get back. We try and get a possible token. If it's not nil, then it means we got something, and let's return it. And so any keywords will get checked for first and returned. And if it's not a keyword, well, it must be a variable, or it's trying to be, or something. And down here, we shift from handle variable to just return nil. And so that check and moving this outside. Okay. This is just a rename. Keywords and names. It's not really gonna, well, it doesn't have names anymore, and it's not going to be just keywords. So I wanted a different name, and I called it find prefix token. Is a sort of a prefix token being the thing that matches the current front of the string. I don't know if there's a real name for that, but that's what I got. All right, and then implementation, rename down there. So straightforward. All right, so we're moving in the old code. This find prefix stuff was being done under the case A through Z. Now we're moving it up to the front. And this is not a refactoring that's in Martin's catalog or anything like that. I have to kind of argue my way through it. And what I know is all my keywords start with A through Z. And so if it were going to go through here and match a keyword A through Z, then it could just as well match it here before the thing. It's almost like I said, if it starts with A through Z, do this stuff, and kind of pulled out this case first. And what that leaves us is just the handle variable. So, moving this up should be safe because it only looks for A to Z star followed by a $sign. And if it works, we return that token. If not, we go back into the program version and just work our way through the case statement and try a handle variable. All right, and so now we're going to take advantage of this. So one thing I want to do is, instead of having a separate approach for one character operators, I want them to map as part of the prefix tokens table. So it was reserved words, now it's prefix tokens, and these formerly characters, now strings, are pulled in here. So the idea is we did this match first. If it starts with a plus, then it must be an addition, okay, that we can match that directly for these one character operands and the new line. All right, and then down in the rest of the switch statement, we don't have to do anything now. We can return nil. It should never get to this case, or even just delete them, okay, because they just kind of can't happen. If they were going to work, they would have been returned in the find prefix token. All right, and this, if you were there for this morning, which fortunately you weren't, I messed this up editing-wise so badly. I tried to use the multi-line editing, and it just didn't happen. Okay, it messed up completely, and I ended up spending more time hand editing it than I would have if I'd just done it in the first place. It should have worked, but it didn't. Okay, but anyway, what we realized, we were running tests and realized, like, hey, our tests are failing randomly, and the reason was these less than, equal, not equal, and less than, they're in this order because you need to match the longer prefix first, because if you look for less than first and you find it, you would just return it. But if the token was actually less than or equal, you would have a less than token followed by an equal token. And that's not what we want to do. We want to actually make one token out of it. And so the order counts. Yet this was a dictionary, and the dictionary was walking through in whatever order it pleased, including varying from run to run. Okay, is part of what the dictionary does. I don't know if that's an intentional thing or just a side effect of some implementation, but because it was inconsistent, we'd run one time, it would pass, and run another time, and it would fail. It's very, very odd. And I remembered my intent had been to have an array, because an array enforces sequence, and we really do want to do these first. Now, we could have, if we had words that contain each other, I don't think we do. No, I don't see any. But if, let's say, go was its own word, we'd have to make sure it came after go to and go sub. Okay, same kind of reasoning. But anyway, we got through that. Ugh. Bizarre seeing random failures. It just doesn't happen that much. All right. And then we had this case returning these operators. Same argument we made before. They can't happen. So let's just return nil in this switch statement, and something can blow up if it needs to. All right. And it didn't. Okay. That's just dead code. Right. So new line, return nil, less than return nil, greater return nil. Those just can't happen. They get handled up here, and this will never get called because of those tokens. So we can delete those switch statement lines, and that makes it all okay. The end result, it's not perfect. No software is, probably. Certainly not much that I write reaches any kind of level like that. But I do think it is simpler to understand and simpler to run. It's probably a little less performant because a hash table tends to do better than an array if it can. We probably could work out some other way, but I think this is all pretty clear. We have a lot of reserved words, and I think you wouldn't struggle too hard to figure out how this reserved word matching works. Okay, so I do think that's simpler and an improvement, less complicated than the state machine we had for those other statements. And the only other thing I did along the way today was I put in some keystrokes. All right, so I defined extract method. Whoops, not like that. Xcode, where are you? Control Command M. All right, well, I'll have to do something that it thinks can be extracted. Maybe this. No. This. Oh, interesting. Oh, I'm in this mode. Okay, let's close this and this. Okay, parser's fine. So this variable, Control Command V, is extract variable. Okay. Control Command M is extract method. All right. And let's undo that. And then Control Command R is rename. Yeah, didn't like it for whatever reason, but it would work if it were appropriate. I'd probably bump something. Let's revert it. And try again. Okay, there it goes. All right. So just so that the refactor menu, my three most common things are dealt with. I don't know what extract all occurrences does. I don't know if that's an extract to method or where it searches to make sure if you use the thing elsewhere. But anyway, I've got those on my keystrokes, and I've learned Control Command back arrow, left arrow to navigate back to a previous file, and both those will speed me up. All right, well, I hope you can join me again in the future. It's weekdays, 10 a.m. to 12:30, so 10 a.m. Eastern to 12:30 p.m. Eastern Time, and 3 to 5:30 p.m. UTC. Thanks for joining, and hope you have a good evening. Bye-bye.